Researchers at ETH Zurich, Empa and EPFL are developing a 3D printed insole with integrated sensors that allows the pressure of the sole to be measured in the shoe and thus during any activity. This helps athletes or patients to determine performance and therapy progress. In elite sports, fractions of a second sometimes make the difference between victory and defeat. To optimize their performance, athletes use custom-made insoles. But people with musculoskeletal pain also turn to insoles to combat their discomfort. Before specialists can accurately fit such insoles, they must first create a pressure profile of the feet. To this end, athletes or patients have to walk barefoot over pressure-sensitive mats where they leave their individual footprints. Based on this pressure profile, orthopedists then create customized insoles by hand. The problem with this approach is that optimizations and adjustments take time. Another disadvantage is that the pressure-sensitive mats allow measurements only in a confined space, but not during workouts or outdoor activities. Now, an invention by a research team from ETH Zurich, Empa and EPFL could greatly improve things. The researchers used 3D printing to produce a customized insole with integrated pressure sensors that can measure the pressure on the sole of the foot directly in the shoe during various activities. The invention was recently featured in the journal Scientific Reports. These insoles aren't just easy to use, they are also easy to make. They are produced in just one step, including the integrated sensors and conductors, using a single 3D printer called an extruder. For printing, the researchers use various inks developed specifically for this application. As the basis for the insole, the material scientists use a mixture of silicone and cellulose nanoparticles. Next, they print the conductors on this first layer using a conductive ink containing silver. They then print the sensors on the conductors in individual places using ink that contains carbon black. The sensors aren't distributed at random. They are placed exactly where the foot sole pressure is greatest. To protect the sensors and conductors, the researchers coat them with another layer of silicone. An initial difficulty was to achieve good adhesion between the different material layers. The researchers resolved this by treating the surface of the silicone layers with hot plasma. As sensors for measuring normal and shear forces, they use piezo components which convert mechanical pressure into electrical signals. In addition, the researchers have built an interface into the sole for reading out the generated data. Tests showed the researchers that the additively manufactured insole works well. At the moment, the researchers still need a cable connection to read out the data. To this end, they have installed a contact on the side of the insole. One of the next development steps will be to create a wireless connection. In the future, 3D printed insoles with integrated sensors could be used by athletes or in physiotherapy, for example, to measure training or therapy progress. Based on such measurements data, training plans can then be adjusted and permanent shoe insoles with different hard and soft zones can be produced using 3D printing.